Good morning everyone. I'm Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today we are going to discuss about oscilloscope. What is the need of oscilloscope? Why we are using this oscilloscope? The main application of oscilloscope is to view the output waveform in CRT screen. We are using this oscilloscope. Normally, if you use an ammeter or voltmeter, we get the output voltage or current. But to view this output voltage and how it varies with respect to time t, that can be observed in CRT screen. So, to observe the output waveform and how it varies with respect to time, we go for these oscilloscopes. And the main part of this oscilloscope is the CRT, that is called as cathode ray tube. With the help of this cathode ray tube, we get the output waveform on this fluorescent screen. This is called as heart of the CRO, and the main parts present in this cathode ray tube are electron gun, anode, X deflection plates, or it is also called as horizontal deflection plates, and Y deflection plates. These are called as vertical deflection plates. And this is the fluorescent screen, which is used to produce the output waveform on the screen. These are the main blocks. And coming to the operation of this cathode ray oscilloscope, when we apply the negative voltage, when we apply the potential, then the electron gun here, the electron gun present here releases the electron beams. These electron beams having more negative potential. So, all the electron beams produced from the electron gun are always trying to move towards the positive potentials. So, the electron beam coming from the electron gun is trying to move towards the positive potential. So, all the electron beams trying to move towards the anode. Now, the electron beam coming from the electron gun will meet the X deflection plates, so that the electron beam potential varies horizontally and it produces the waveform on fluorescent screen. Similarly, the electron beam passing through the vertical deflection plates or Y plates produces the electron beam spot vertically from top to bottom or bottom to top. Similarly, the electron beams moves horizontally from left to right and right to left. Like this, the vertical and horizontal deflection plates produces the electron beam spot movement vertically and horizontally. If you observe this, the electron beams coming from the electron guns, if you observe this, if the electron beam coming from the electron gun, that electron beam will spread in different directions. But there exists one control grid. With the help of this control grid, we can make all the electron beams should be formed and focused in one particular direction, so that all the electron beams coming from the electron gun will be focused in one particular direction. As the number of electron beams formed or focused in one particular direction, then the intensity of the electron beam increases. As the intensity of the electron beam increases, it produces bright spot on the fluorescent screen. So that with the help of control grid, we make that all the electron beams coming from the electron gun should be passed through a particular direction, or all the electron beams coming from the electron gun formed at one particular position and passing through this X and Y deflection plates. When the electron beam having more intensity, if this electron beam meet the X deflection plates, or it is also called as horizontal deflection plates, will produce the electron beam spot movement horizontally from left to right or from right to left. Similarly, if the same electron beam meet the vertical deflection plates, then the electron beam spot produces vertically from bottom to top or from top to bottom. Like this we get the X and Y deflection plates produces the electron beam spot on fluorescent screen. With the help of this electron beam spot, we can produce the waveform on fluorescent screen or phosphorus screen. So this is called as heart of the CRO or cathode ray oscilloscope. And coming to this cathode ray tube, the first diagram represents the main elements present in cathode ray tube. And this diagram indicates what are the different elements present in the cathode ray tube. Along with the main elements, there are so many other elements. That is, in the first diagram, we have only one anode, but that anode internally consists of focusing anode, accelerating anode, and pre-accelerating anode. We have three anodes: focusing anode, accelerating and pre-accelerating anodes. And we have the phosphorus screen. This phosphorus screen is coated with the aqueduct coating. As it coated with this aqueduct coating, we can view the output waveform on the CRT screen for certain time. So these are the internal parts present in cathode ray tube. As we already discussed about this cathode ray tube, this is heart of the CRO or cathode ray oscilloscope. This oscilloscope mainly consists of vertical deflection plates, horizontal deflection plates. Along with this, we have cathode, anode and electron gun. And this is the base. As we apply the potential, then the electron gun releases the electron beam. These electron beam having more negative potential. So, the electron beam with more negative potential always trying to move with positive potential, so that the electron beams are moving towards anode potentials. So, as the electron beam coming from the electron gun, it will spread in different directions. So that as the electron beam will spread in different direction, the intensity of electron beam will reduces. So that with the help of control grid, we make that all the electron beams coming from the electron gun should be focused in one particular direction. Like that, the electron beam will be formed and focused in one particular direction. This electron beam trying to meet this anode potential. In this anode, we have three types: pre-accelerating anode, focusing and accelerating anode. Before applying this to this accelerating anode, we have pre-accelerating anode. As the electron beam meet the pre-accelerating anode, its intensity level will increases, and with the help of focusing anode in one particular direction, all the electron beams will move. As the electron beam will move in one particular direction towards anode potential, its intensity level will increases. At the same time, towards one particular direction, its focus also increases. And finally, the electron beam coming from electron gun reach the vertical plates and horizontal plates. As it reaches the vertical deflection plates, it moves the electron beam spot vertically from top to bottom and bottom to top. Similarly, if it meets the horizontal deflection plates, it moves the electron beam spot horizontally from left to right and right to left. In this way, we get the output waveform on the CRT screen. With the help of aqueduct coating that is present on the phosphorus screen, we can able to see the waveform on the screen. This is about cathode ray tube. And as we know that the main part of this CRO is cathode ray tube. In this cathode ray tube, the important parameters are deflection plates, vertical deflection plates and horizontal deflection plates. And this is the system for internal architecture for vertical deflection system. As we know that one CRT consists of one set of vertical deflection plates and one set of horizontal deflection plates. Coming to this vertical deflection system, it consists of one set of vertical deflection plates. Here we have P1 and P2, two deflection plates, and one deflection plate is given to the connected to positive potential, whereas second deflection plate is connected to negative potential. As the two deflection plates, one is connected to positive and another one is connected to negative potential. If you observe here, P1 is connected to positive potential, whereas P2 is connected to negative potential. If the electron beam passing through this vertical deflection system, as we know that the electron beam having negative potential, so that it always trying to reach positive potential. That's why all the electron beams coming from the electron gun trying to move towards positive potential. Which one is positive potential means P1. So that's why all the electron beam coming from electron gun meet at the point Y1, because this Y1 indicates the point where the P1 has more positive potential compared with P2. In the next time, if you connect P2 to the positive terminal and P1 to the negative terminal, then all the electron beam coming from electron gun trying to move towards P2, so that it produces the electron beam spot at point Y2. Like that, as the potentials varies across the points P1 and P2, the electron beam spot produces the points on fluorescent screen or phosphorus screen. Similarly, if P1 and P2 having compared to the electron beam potential and P1 and P2 having more negative potential, then the electron beam spot will be produced at the center of the CRT screen. Compared to the electron beam potential, the P1 and P2 having more negative potential means then the electron beam spot will be produced at the point origin. In this way, with the help of P1 and P2 and the potential which are connected to this P1 and P2 vertical deflection system, the electron beam spot moves vertically from top to bottom and bottom to top. Similarly, we have horizontal deflection system. This is horizontal deflection system. So that cathode ray oscilloscope consists of CRT. In that CRT, we have vertical and horizontal deflection systems. In this horizontal deflection system also we have one set of horizontal deflection plates. So in this one set of horizontal deflection plates, one plate is connected to positive potential and another one is connected to the negative potential. In this case, H1 is connected to negative potential and H2 is connected to positive potential. If the electron beam coming from the electron gun trying to reach the positive potential, because the electron beam having more negative potentials, so that all the electron beams coming from electron gun trying to meet at the point X2, so that we have electron beam spot at the point X2. Similarly, if you change the potentials of H1 and H2, H1 is connected to positive polarity and H2 is connected to negative polarity. Now, H1 is connected to positive polarity and H2 is connected to negative polarities. As the polarities changes, the electron beam spot will be produced at the point X1. Like this, the electron beam spot varies horizontally from left to right or right to left. With the help of polarities, we are connecting to the deflection system. So, this is called as horizontal deflection system. With the help of this horizontal deflection system, we can produce the electron beam spot horizontally from left to right or from right to left. Cathode ray tube. This cathode ray tube is the heart of the cathode ray oscilloscope. This cathode ray tube is mainly used to represent the output waveform on fluorescent screen. So this is internally present in cathode ray oscilloscope. The cathode ray oscilloscope is mainly used to produce any waveform on the CRT screen. At the same time, how it varies with respect to time t can also be observed with the help of oscilloscope. So in this oscilloscope, the main part of the oscilloscope is CRT. This is the block diagram representation of cathode ray tube, and this is how internal parts are present in the cathode ray tube, how it works. If you observe this cathode ray tube, it consists of electron gun, vertical deflection plates, horizontal deflection plates, phosphorus screen and control grid. As we provide the potential, then the electron gun releases the electron beams. All the electron beams are trying to move towards the positive potentials, so that the electron beam will be distributed in different directions. But if the electron beam is distributed in different directions, its intensity level will reduces. To increase the intensity level of electron beam, we are using this control grid. With the help of control grid, we focus all the electron beam to be positioned in one particular direction, so that all the electron beams will be formed and focused in one particular direction. These electron beams having more negative potential, so it is trying to move towards positive potential. So first the electron beam meet the pre-accelerating anode. As it meets the pre-accelerating anode, it increases its intensity level and it next reaches the focusing anode. With the help of this focusing anode, the electron beam will reach a particular point on the CRT screen. Then with the help of vertical and horizontal deflection plates, the electron beam spot moves vertically and horizontally on the CRT screen. Here the CRT screen is coated with the aqueduct coating. As it is coated with this aqueduct material, we can view the output waveform on CRT screen for certain duration. Whenever we apply the input to the CRO, it produces the output on the CRT screen. So with the help of this phosphorus screen, we can able to view the waveform. And in this cathode ray tube, the main elements are vertical and horizontal deflection plates. And this is the diagrammatic representation of vertical deflection plates, and this is horizontal deflection plates. With the help of this vertical and horizontal deflection plate, we can view the electron beam spot movement vertically and horizontally from left to right or top to bottom or bottom to top. This is about CRT and its internal parts, how it produces the waveform on CRT screen. And the prescribed textbook is Kalsi. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.